In this video, we'll be talking about the definite integral interpreted as an area. Definite integrals can be positive, negative, or zero. And in order for a definite integral to be interpreted as an area, the function must be continuous and non-negative on a closed interval from a to b. The theorem is if f is continuous and non-negative on the interval from a to b, then the area of the region bounded by the graph of f, so the graph of f is this squiggly line I've shown right here, the x-axis right here, and vertical lines x equal a and x equal b. So the region enclosed in here, I've shaded it in, is defined to be the definite integral from a to b of f of x dx. I've also shown a representative rectangle so that you can see where your dx is also. For a region bounded by the graph of f, the y-axis and horizontal lines y equal a and y equal b. So here's our function, our y-axis, and then horizontal lines a and b. Then the area of that region, right in there, that's shaded, can be found by finding the definite integral from a to b of f of y dy. For now, you can evaluate a definite integral with the limit definition, or if the integral represents the area of a common geometric figure, use formulas from geometry. Our first example is to evaluate the definite integral from 0 to 3 of the function x plus 2 times dx. We'll first do this with the limit definition, and then we'll take a look at it with the geometry formula. First thing we want to do is find delta x. Remember, this is the formula we use to find delta x. So we're going to take 3 minus 0 divided by n. So delta x is 3 over n. Then we also need to find c sub I, and this is the equation that we use to find that. So for our problem, c sub I is 0, which is our left boundary, plus I times 3 over n. So c sub I is 3i over n. Then also I'm going to show my function. If f of x is x plus 2, then f of c sub I, we're just going to sub in c sub I, which is 3i over n, into my function in place of x. So f of c sub I is 3i over n plus 2. And then our theorem, I want to show that again for reference. Our theorem says that the area is the definite integral from a to b of f of x dx, which we can find by taking the limit as n approaches infinity of the summation as I goes from 1 to n of f of c sub I times delta x. Now for our example, then our area is the integral from 0 to 3 of x plus 2 dx, the limit as n approaches infinity of the summation as I goes from 1 to n. This is our f of c sub I, which we wrote right here, and then this is multiplied by delta x. Now we can do some simplifying. This factor of 3 over n we can pull in front of the summation. So that's out in front here. And then I can split this binomial into the summation of each of the terms separately. So the summation as I goes from 1 to n of 3i over n, that's this first term. And then plus the summation as I goes from 1 to n of 2. Now we're going to use our summation formulas. My 3 over n is still outside of the brackets. My first term, 3i over n, my 3 over n I can write separately, and then that's multiplied by, and the summation formula for I is just n times n plus 1 over 2. Plus, and then the formula for summation of a constant, you take your constant times the upper limit of summation, and I have 2 times n. Okay, now if I multiply these out, I have 9n squared plus 9n over 2n squared. That's our first term here. And then multiplying 3 over n times 2n, I have 6n over n. So simplifying, we can break this fraction up into 2 separate fractions. That'll be 9 over 2. My second one will be 9n over 2n squared, which when I do a limit on that goes to 0. And then 6n over n is just 6, and since there's no n's there, the limit is 6. The sum of these constants is 21 over 2. So the area shown as that definite integral from 0 to 3 of x plus 2 dx is equal to 21 halves. Now if we look at that in geometry, we can see that the function x plus 2 is just a line with y-intercept of 2 and a slope of 1. So this is my function. My boundary, they're going from 0 to 3. So my region that I want to find the area of is just this trapezoid. And the formula for trapezoid area is 1/2 the height times the sum of the bases. My bases are the parallel sides. So this base right here is 2 units, which I've shown right here. This base is 5 units, which is right here. And then the height is the distance between the 2 bases. So my height is 3. So the area of the trapezoid can be found with this geometry formula, and we get 1/2 times 3 times 7, which is 21 halves. Now in this example, we're asked to evaluate the definite integral that goes from -2 to 2 of the square root of 4 minus x squared dx. This definite integral must be evaluated using geometry formulas. We don't have a method for evaluating this integral as it is. So we have to look at this function and see if we can recognize it as a geometric figure that we know how to find the area of. So first of all, let's write the function as y equals radical 4 minus x squared. Square both sides and rearrange the terms. So when you square both sides, you get y squared equals 4 minus x squared. Now if we add our x squared to the left side, we get x squared plus y squared equals 4. Hopefully you'll recognize this as the equation of a circle with a center at 0, 0 and a radius of 2. So the region that we want to find its area is a semicircle, and the reason it's a semicircle is because if you went from this step back to this step where we have to square root both sides, we would actually have plus or minus in front of the radical. So the plus part is the one that we're dealing with, and that's going to be the semicircle above the x-axis. We know that the area of a circle is pi r squared, so the area of the semicircle is 1/2 pi r squared. Plug my radius of 2 in here in place of r, so I have 1/2 pi times 2 squared, so the area of this region is 2 pi.